Hi, everyone, and welcome to another episode of Supply Chain Certified. Today, I'd like to talk about a topic that's becoming increasingly critical for manufacturers worldwide. It's called China Rare Minerals and Compliance Strategies. I'm your host, Kunal Chopra, and today we're going to dive deep into what manufacturers need to know about rare earth minerals, China's dominance in this market, and more importantly, practical strategies for ensuring compliance and business continuity. So if you're a business executive, operations manager, or compliance professional in an industry that relies on rare earth minerals, whether directly or through your component suppliers, this episode is essential listening. The regulatory landscape is changing rapidly, with China's recent export controls creating significant challenges for global supply chains. So in the next 30 to 40 minutes, we'll cover everything from the basics of rare earth minerals to detailed, actionable strategies for navigating compliance requirements and building supply chain resilience. We'll examine case studies from companies that have successfully adapted to these challenges and provide a step-by-step implementation plan that you can begin executing immediately after this episode. So with that being said, let's get started. Let's start with the fundamentals, understanding what rare earth minerals actually are and why they matter so much to modern manufacturing. So this first section is what I call understanding rare earth minerals. So despite their name, rare earth minerals aren't particularly rare in the Earth's crust. They comprise a group of 17 metallic elements in the periodic table, the 15 lanthanides plus scandium and yttrium. Now, what makes these elements challenging isn't their scarcity, but it's rather their geochemical properties. They're rarely found in concentrated deposits, instead typically occurring dispersed within other minerals, which makes extraction and processing technically difficult and environmentally challenging. Now, these 17 elements are typically categorized into two groups, light rare earth elements, or LREEs, which include lanthanum, cerium, praseodymium, neodymium, promethium, samarium, and europium. I hope I got these names right. They are generally more abundant and somewhat easier to process. Then we have the heavy rare earth elements, or HREEs, which include gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. Again, I hope I got these names right. These tend to be scarcer and more valuable. Additionally, out of those 15, there are two others, scandium and yttrium. These are often grouped with the rare earths due to similar chemical properties. So it's crucial for manufacturers to understand that as of April 2025, China has imposed specific export controls on 7 of these elements. And those are samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium. These controlled elements are particularly critical for high-performance magnets, electronics, and defense applications. So the question I think we should all be asking is, why do these materials matter so much? Rare earth elements have become indispensable across numerous industries due to their unique magnetic, luminescent, and electrochemical properties. So let me give you some more concrete examples. Let's take the example of electronics. In electronics, elements like neodymium, praseodymium, and dysprosium are crucial for miniaturized components, speakers, vibration motors in smartphones and computers. Europium, yttrium, and terbium create the vibrant colors in displays and LED lighting. The automotive industry relies heavily on rare earths for electric vehicle motors, with each EV containing approximately 1 to 2 kgs of rare earth magnets. They're also used in catalytic converters, sensors, and battery technologies. In renewable energy, rare earths are essential for the permanent magnets in wind turbine generators, with each large turbine requiring up to 600 kgs of rare earth materials, and in various components of solar panel systems. The healthcare sector depends on rare earths as well for their MRI machines, which use significant amounts of gadolinium, surgical lasers, and various medical devices. The defense industry is another one. They are particularly vulnerable to rare earth supply disruptions, as these elements are critical in precision-guided munitions, radar systems, night vision equipment, and satellite communications. And then you have manufacturing broadly. Rare earths enable high-precision tools, industrial magnets, and advanced robotics. So understanding these applications is crucial for manufacturers to identify their exposure to rare earth supply chain risks and to prioritize compliance and continuity efforts for the most critical components and products in their portfolio. The rare earth supply chain is quite complex and technically challenging, consisting of multiple stages that require specialized expertise and infrastructure: mining, separation, processing, refining, alloying, component manufacturing, and finally, end product integration. China's dominance is most pronounced in the middle stages of this chain, particularly in processing and refining, where technical barriers to entry are the highest and environmental challenges are the most significant. So this creates a bottleneck in the global supply chain, as even rare earths mined outside of China often must be sent there first for processing. So that's the big picture on what these rare earths are. That's the big picture on their applications. That's the big picture on China's dominance in this industry when it comes to supply chain. So now that we understand what rare earth minerals are and why they're so important, let's examine in a little more detail China's dominance in the market and how it reflects and affects global manufacturers. So this is moving on to section 2, which is China's dominance in the rare earth market. Understanding the historical evolution of the rare earth market provides crucial context for today's challenges. From the 1950s to the 1960s, the United States dominated global rare earth production, with the Mountain Pass mine in California serving as the primary resource for the world. But in the 1980s, China began a strategic investment in its rare earth industry, with then leader Deng Xiaoping famously declaring, "The Middle East has oil, China has rare earths." This statement reflected China's recognition of the strategic value that these minerals would have in the emerging high-tech economy. Throughout the 1990s and 2000s, China steadily increased production while offering lower and lower prices, driving competitors out of business and achieving market dominance. This was accomplished through several advantages: strategic government investment and subsidies, less stringent environmental regulations historically, lower labor and production costs, aggressive pricing strategies to eliminate competition, acquisition of foreign technology and expertise, and development of a complete industrial ecosystem. A pivotal moment occurred in 2010 when China restricted rare earth exports to Japan during a territorial dispute over the Senkaku Diaoyu Islands. This demonstrated the geopolitical leverage that control of these materials provides and triggered global awareness of supply vulnerabilities. Fast forward to 2025, between 2020 and 2025, geopolitical tensions have accelerated, leading to increased investment in non-Chinese rare earth production and processing facilities. The situation reached a new inflection point in April 2025, about a month before the recording of this episode, when China's implementation of export controls on 7 critical rare earth elements. Now, China's position in the global rare earth market today represents one of the most successful examples of strategic resource control in modern history. China controls 60 to 70% of global rare earth mining production, dominates approximately 90% of global processing and refining capacity, produces about 85% of rare earth magnets worldwide, maintains strategic stockpiles of critical materials, has an integrated supply chain from mining to end products, and possesses unmatched technical expertise in processing and application. China's rare earth production is concentrated in 3 main regions. Number 1, Inner Mongolia in the north, particularly rich in light rare earths, the REEs that we discussed. Sichuan in the southwest, and Jiaxing in the southeast, which contains a significant deposits of heavy rare earths. The Bayon Ob mine in Inner Mongolia stands as the world's largest rare earth mine. Since 2014, China has consolidated its rare earth industry under 6 state-owned enterprises: China Minmetals Corporation, the China Aluminum Corporation, China Northern Rare Earth Group, the China Southern Rare Earth Group, Xiamen Tungsten, and Gunao Rare Earth Group. This consolidation has enhanced central government control over the sector. This monopoly that China has over rare earth confers several strategic advantages that extend far beyond simple economic benefits. These include economic leverage in trade negotiations, influence over manufacturing location decisions, access to cutting-edge technology, support for domestic industries, a geopolitical tool in international relations, value-added revenue, and positioning in emerging technologies. And understanding these strategic dimensions is crucial for manufacturers, as they indicate that China's rare earth policies are driven by broader national objectives rather than purely commercial considerations. So with that being said, now that we understand China's dominance in this market, let's now turn to the evolving regulatory landscape and what it means for manufacturers. And that's moving to section 3, which is the compliance challenges for manufacturers. China's regulatory framework for rare earth elements has evolved significantly over the past decade, transitioning from basic resource management to sophisticated strategic control. This evolution reflects the Chinese government's growing recognition of rare earths as critical strategic resources with both economic and geopolitical value. The cornerstone of the regulatory framework is the Regulations on the Management of Rare Earths, which took effect in October of 2024. These comprehensive regulations formalized China's approach to rare earth management, designating these materials as strategic resources and establishing a framework for their protection, development, and utilization. Key provisions of these regulations include the establishment of a national strategic reserve system, quota management for mining, processing, and separation, traceability requirements throughout the supply chain, enhanced environmental protection standards, and severe penalties for illegal mining and processing. China's export control law, originally enacted in 2020, has been increasingly applied to rare earth materials, culminating the April 2025 export controls. On April 4th, 2025, China's Ministry of Commerce and General Administrative of Customs issued Announcement 18, implementing export controls on 7 specific rare earth elements. This measure represents the most significant restriction on rare earth exports since 2010, quota reductions that triggered the international disputes that we talked about. This announcement establishes a licensing requirement for the export of samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium. Importantly, these controls extend beyond the pure elements to include their oxides, alloys, compounds, and mixtures, effectively covering the full range of commercially valuable forms. The Chinese government cited national security concerns and international non-proliferation obligations as the official rationale for these controls, though many analysts view them as a strategic response to escalating trade tensions and technology restrictions imposed by Western countries. The licensing requirements for rare earth exports from China create a complex regulation compliance landscape that manufacturers now must have to navigate carefully. Applications must be submitted through MOFCOM with required documentation including end-user certificates, purchase contracts, and technical specifications. Materials must be classified under China's dual-use item control codes. Additional custom declaration procedures apply. Processing times typically will vary from 30 to 45 days, and approved licenses generally have a validity period of 6 months. China has established robust enforcement mechanisms to ensure compliance, backed by significant penalties for violations. These include rigorous inspection and verification procedures, material testing and certification requirements, administrative penalties for license violations, potential criminal liability, blacklisting in China's corporate social credit system, suspension of export privileges for repeat offenders, and joint liability between Chinese suppliers and foreign buyers. So I think everyone listening to this podcast, I'm sure you're asking the question, what does this really mean for manufacturers? The export controls and regulatory changes in China's rare earth sector create immediate and tangible impacts on manufacturing supply chains worldwide. First, then there are increased lead times. The licensing process adds 30 to 45 days to procurement cycles, disrupting just-in-time inventory systems and production scheduling. Number two, price volatility has become a significant challenge, with costs for some controlled elements increasing by 50 to 200% following the announcement of export controls, necessitating a more sophisticated cost management strategies. Documentation and certification requirements have expanded substantially, requiring manufacturers to obtain detailed information about material composition, origin, processing history, information that some suppliers may be reluctant or unable to provide. Supplier reliability has become a pressing concern, as even long-standing supplier relationships face uncertainty due to factors outside suppliers' control, such as license approval decisions by Chinese authorities. So these challenges effectively create, the risk of production disruptions, particularly for manufacturers with lean inventory manufacturing practices or specialized material requirements. When seeking alternative sources outside of China, manufacturers often encounter quality consistency issues, as less experienced processors may struggle to match the specifications and performance characteristics that these Chinese materials provide. Perhaps most concerning from a competitive standpoint, Chinese manufacturers may gain advantages through preferential access to these critical materials, potentially allowing them to maintain production while international competitors face shortages. So let's look at how some companies have responded to these challenges. One example is from the automotive industry. That industry provides valuable insights into effective adaptation to rare earth supply challenges, particularly as electric vehicle production has increased dependency on these materials. Let's go back in history again, back to that 2010 export restrictions that we talked about. So following the 2010 export restrictions that severely impacted Japanese manufacturers, Toyota, what they did was they implemented a comprehensive response strategy. The company developed reduced dysprosium magnets that maintained performance while decreasing dependency on one of the most supply-constrained rare earth elements. Now, this innovation, required close collaboration between product engineering and procurement teams, demonstrating the importance of a cross-functional approaches to supply chain challenges. Tesla took a completely different approach by designing some models with the switched reluctance motors that eliminate rare earths requirements entirely, though with some performance trade-offs. This example highlights the potential for design-based solutions when they align with product requirements and customer expectations. The electronics industry is another example. Their response offers some complementary insights as well. Apple has pioneered material recovery and recycling initiatives, developing specialized robots that can extract rare earth components from end-of-life devices for reuse in new products. Samsung is another example. They implemented a comprehensive supplier diversification strategy, qualifying multiple sources for critical components and materials while investing in the development of suppliers outside of China. So with that being said, let's now turn into some strategies that you could implement to address some of these challenges. And can you learn from some of these other companies in the wake of the current situation? This is section 4, which is all about business continuity strategies. A robust risk assessment framework provides the foundation for effective business continuity planning in the context of rare earth dependencies. Now, this framework should begin with a structured approach to evaluating supply chain vulnerability, examining each point whether rare earth elements enter your operations, whether as raw materials or embedded in components. The impact assessment should, quantify the criticality of each rare earth dependent item to your products and operations, considering factors such as revenue contribution, customer requirements, and substitution difficulty. Probability analysis must evaluate the likelihood of supply chain disruptions for specific materials, considering factors such as source concentration, geopolitical tensions, and regulatory trends. Time horizon considerations are also crucial as different strategies apply to immediate risks, let's say 0 to 6 months, medium-term challenges, let's say 6 to 24 months, and then more long-term structural issues, let's say 2 to 5 years. Both quantitative methods such as financial impact modeling and statistical supply risk analysis, qualitative approaches including scenario planning, expert judgment, should be employed, in our opinion, for a very comprehensive assessment. This process requires cross-functional input from procurement, engineering, finance, legal, even executive leadership to ensure and capture all dimensions of risk. The resulting assessment, should be thoroughly documented and subject to regular reassessment as market conditions, regulations, and your product portfolio evolve. Supply chain diversification represents a fundamental strategy for reducing rare earth vulnerability, though it requires careful planning and execution to be effective. Geographic diversification of suppliers should focus on developing sources outside China, particularly in countries with stable regulatory environments, strong trade relationships with your home market. Material form diversification provides additional flexibility for qualifying suppliers for different forms of same elements, oxides, metals, alloys, and finished components, allowing you to adapt to availability at different points in the value chain. Qualifying multiple suppliers for each critical material creates redundancy, though this process can be resource intensive and time consuming, particularly for specialized or high performance applications. A tiered approach based on criticality and risk allows you to focus diversification efforts where they matter most, with the most critical materials requiring the most robust diversification. For emerging suppliers with promising capabilities but current limitations, supplier development investments can accelerate the ability to meet your requirements through technical assistance, equipment financing, or long-term purchase commitments. Alternative sourcing options for rare earth materials are expanding, though most remain in early development compared to China's established capacity. Australia is one example that has emerged as a leader in non-Chinese supply, with the Rhinas Rare Earths operating the world's largest integrated rare earth mining and processing operation outside China. In the United States, MP Materials has started the Mountain Pass mine in California and is developing processing capabilities. Canada hosts several promising developments, including Vital Metals, a Nekalako project, which began production in 2021. Material substitution offers a powerful strategy as well for reducing rare earth dependency, though that typically involves navigating performance trade-offs and development investments. An engineering assessment of substitution options should be conducted for all critical rare earth applications in your products, evaluating both direct material substitutions and alternative technologies that eliminate rare earth requirements entirely. Performance trade-offs must also be carefully evaluated and customer impact assessed, as substitutions often involve compromises in size, weight, and efficiency, or durability that may affect product positioning or customer acceptance. Near-term substitution approaches typically focus on reducing quantities of the most supply-constrained elements while maintaining the same basic technology, while long-term approaches may involve more fundamental technology changes. Recycling and circular economy approaches are gaining traction as well, as both sustainability initiatives and supply security strategies for rare earth materials. End-of-life product recovery systems represent the foundation of these efforts, with manufacturers increasingly implementing take-back programs for products containing significant rare earth content. Disassembly and separation technologies have advanced significantly, with specialized processes now capable of recovering rare earth elements from magnets, phosphors, and other components with sufficient purity for use in manufacturing. In-process scrap recycling offers more immediate opportunities as production waste containing rare earths can be more easily recovered than materials in finished products. Strategic partnerships and alliances offer collaborative approaches to rare earth challenges that can be more accessible than vertical integration while providing many of the same benefits. Supplier developmental partnerships involve working closely with emerging rare earth producers or processors to accelerate their capabilities through technical assistance, market knowledge, financial support, in exchange for preferential supply access. Customer collaboration on material requirements provides opportunities to align specifications with material availability, potentially adjusting performance parameters or accepting alternative materials where they don't compromise essential functionality. Industry consortium approaches pool resources from multiple manufacturers with similar needs, creating sufficient scale to support new suppliers, fund research initiatives, or develop shared infrastructure. So now that you have a list of all these different strategies, let's discuss how to implement these strategies in a more structured, phased approach. And that's section 5 here, which is about implementing an actionable implementation plan. What we recommend here at Certivo is that the first 3 months of your rare earth compliance and business continuity journey should focus on establishing foundational capabilities and addressing immediate vulnerabilities. Begin with a comprehensive rare earth dependency assessment that identifies all points where these materials enter your supply chain, whether as raw materials or embedded in components. Establish a cross-functional rare earth task force with representatives from procurement, engineering, quality, compliance, executive leadership to coordinate your response and ensure all perspectives are considered in decision-making. Implement a structured supplier communication protocol to gather information about rare earth content, processing locations, and compliance preparations from your supplier base. Develop documentation and verification procedures that meet current regulatory requirements, including systems for maintaining records of material composition, origin, processing history, and export licenses where applicable. Create an inventory management strategy for critical materials that balances risk reduction against carrying costs, potentially increasing safety stocks for the most vulnerable items. Establish a monitoring system for regulatory developments related to rare earths and initiate compliance training for key personnel across functions, ensuring they understand the regulatory requirements, business implications, and their specific responsibilities in your rare earth management strategy. The medium-term phase of your implementation plan covers months 3 through 12. That's really focusing on developing structural solutions to rare earth challenges while strengthening your compliance capabilities. Before qualifying alternative suppliers for your most critical rare earth materials, conducting thorough technical and commercial evaluations to ensure that they can meet your requirements. Develop a material substitution roadmap that identifies opportunities to reduce dependencies on the most vulnerable rare earth elements, prioritizing projects based on technical feasibility, implementation timeline, and risk reduction potential. Implement enhanced supply chain mapping that extends visibility beyond direct suppliers to understand the complete path of rare earth materials from mining to processing to your operations. Establish recycling and recovery programs for both production scrap and end-of-life products containing significant rare earth content, starting with the most economically viable opportunities. Create scenario-based contingency plans for different types of supply disruptions with specific response protocols, trigger points, and decision authorities defined in advance. Revise supplier agreements to address compliance requirements explicitly and integrate rare earth considerations into your product development process with design guidelines that encourage material efficiency, substitution where possible, and design for recycling approaches. Long-term resilience building extending from 1 to 5 years focuses on structural transformations that fundamentally reduce rare earth vulnerability while potentially creating competitive advantages. Consider strategic investments in supply chain development, which might include minority stakes in mining or processing ventures, joint ventures with emerging suppliers, or direct funding of supply expansion projects in exchange for offtake agreements. Establish R&D programs for alternative materials and technologies that can reduce or eliminate dependency on the most vulnerable rare earth elements. Conduct a thorough vertical integration opportunities assessment to evaluate whether direct ownership of certain supply chain stages would provide sufficient benefits to justify the investment and operational complexity involved. Pursue industry consortium participation and potentially leadership, working with peers to develop shared solutions to common challenges. Engage in policy advocacy and government relations to shape emerging regulations and support programs in ways that align with your needs. Ensure comprehensive integration of your rare earth strategy with broader business planning processes, and explore opportunities for competitive differentiation through supply chain resilience. An effective internal rare earth task force provides the organizational foundation for implementing your compliance and business continuity strategies. The optimal organizational structure involves typically a core team with dedicated responsibilities, supplemented by extended members who participate as needed for specific initiatives. Key roles within the task force should include a program leader with overall responsibility for coordination and process, a technical specialist who understand material properties and applications, procurement representatives who manage supplier relationships, compliance experts familiar with relevant regulations, and finance personnel who can assess cost implications and investment requirements. Establish clear metrics and key performance indicators, or KPIs as we all know them. That's really essential for tracking progress, demonstrating value, and guiding continuous improvement in your rare earth management program. Compliance performance metrics should include both leading indicators like documentation completeness, supplier certification rates, and lagging indicators such as audit findings or compliance incidents. Supply chain resilience indicators measure your progress in reducing vulnerability, including metrics like supplier diversification percentage, inventory coverage for critical materials, qualified alternative material availability, and actual performance during disruption events. Cost management effectiveness measures track both the expenses associated with your rare earth initiatives and the financial benefits that they can deliver. A balanced scorecard approach integrates various metric categories into a comprehensive view of performance that prevents overemphasis on any single dimension, ensuring that compliance, resilience, cost, and implementation are all receive the same appropriate attention. So that's kind of it at the highest level. We covered a lot in this episode, but as we conclude this episode, let's summarize some of the key insights that should guide your implementation efforts. We've explored China's dominance in rare earth mining, processing, component manufacturing, and we understand that it creates significant compliance and business continuity challenges for manufacturers worldwide. We have examined the evolving regulatory landscape, including the recent export controls on 7 critical rare earth elements and their implications for global supply chains. We have discovered practical approaches to compliance, from documentation requirements to supplier engagement strategies. We've outlined a comprehensive framework for building resilience through diversification, substitution, recycling, strategic partnerships. And the critical success factors for implementation include executive level commitment, cross-functional coordination, balanced investments across short and long-term solutions, and consistent monitoring of both regulatory developments and your own progress. Common pitfalls to avoid include focusing exclusively on compliance without addressing underlying supplier vulnerabilities, pursuing diversification without adequate quality control, and treating rare earth management as a one-time project rather than an ongoing strategic priority. Your immediate next steps should include establishing your rare earth task force, conducting a comprehensive dependency assessment, and implementing basic compliance documentation systems while developing your longer-term strategy. Remember that rare earth management requires ongoing learning and adaptation as regulations evolve, technologies advance, and as market conditions change. Finally, recognize that while rare earth challenges create significant risks, they also present opportunities for competitive differentiation. Companies that develop sophisticated approaches to compliance and resilience can ensure business continuity while competitors struggle, potentially gaining market share and customer loyalty during supply disruptions. By implementing the strategies we've discussed today, you can transform rare earth management from a compliance burden to a strategic advantage for your organization. So again, thank you for listening to this episode. For more resources on this topic, including detailed implementation guides, supplier questionnaire templates, and regulatory updates, please visit our website at certivo.com. And until next time, this is Kunal Chopra, your host, signing off. Thank you so much.